Good morning, children. In today's class, we'll discuss the concept of ray diagram from the concept of physics. Before going to discuss this ray diagram, I will explain you, I will use some example how it will be useful in the day-to-day life. Have you ever seen the movie Doom? In that movie, Hrithik Roshan, he theft a diamond in the museum. After removing the diamond from the place of diamond, he creates an illusionation and a virtual diamond will be placed over there. Virtual means actual object will not be present over there, but it seems to be present there. Such an illusionation he creates. Is it possible in real life? Yes. How it is that to understand that? First of all, we should be aware of some basic things. I will explain the basic things and then we can discuss by using the concept of ray diagram. How can we create such illusions? Okay? First of all, take a candle. Every source in the universe, that may be a sun or a candle or a bulb, all the light sources, they release light rays in all the directions. From the point of release, if you compare two light rays, in the direction of progression, gradually the distance increases. Such kind of light rays, bunch of light rays has another term, that is beam. Such kind of bunch of light rays in which the distance increases. This is called diverging beam. If you consider the two light rays at the source which are very close to each other, these are very close to each other, have very less angle. Such kind of light rays, if they travel infinite distance, very long distance, then these two light rays acts like a parallel beam. Parallel means the distance is same. In mathematics, there is a law: no two parallel lines intersect even though they extend up to infinity. But in physics, the light rays which are very closely delivered at one point after traveling an infinite distance, they seem to be and it behaves like a parallel rays. And in some of the cases, the light rays they converge. I will explain in ray diagram in which case and why. Okay. Converging means in the direction of progression, the distance between the light rays gradually decreases, and finally the light rays intersect at one point. If the light rays intersect at one point, such a beam is called converging. So this is one basic idea you should have to understand the concept of ray diagram, that is diverging, parallel, converging. And the next one is, you know well, laws of reflection and laws of refraction. A brief idea: if a light ray travels through a parallel medium to a denser medium, this is let it be incident light ray which fall passing through the air fall on the surface of the interface. Interface separates air and water. Then at the point of incidence, if you consider the perpendicular called normal, and the angle between incident and normal is angle of incidence. Here light ray moving from one medium to another medium, having different density. This is denser medium, this is rarer medium, having different optical densities. As a result, when light ray enters into the denser medium, it bends, means it closely passes towards the normal, passes through the second medium, very close to the normal. Means here the angle is, it is refracted. Means the light ray is deviated. Such a light ray is called refracted. This refracted light ray makes some angle with the normal, that is called angle of refraction. This angle of refraction is less when the light ray moves from rarer to denser. This angle of its refraction is more when light ray moves from denser to rarer. If it is in opposite direction, if you consider like this, then incident ray angle is less and refracted angle is more. Always the angle made in rarer medium more, angle made in denser medium less. This is the key point to remember. Next. Yes. For example, if you take a surface interface, okay, let this is the light ray incident on the interface. Okay, for this curvature, let it be principal axis and center of curvature to the entire curvature, and this is pole, and the midpoint between the center of curvature and pole is nothing but focus, and the length from here to here is focal length, and from pole to center of curvature is radius of curvature. These are all things we learned in the previous chapter. Okay. Now, if an incident light ray incident or on the concave surface on the interface at a concave surface. Here, let this is rarer medium and this is denser medium. Okay, and you know well in curved surfaces the normal, how to detect the normal. That is a line, to draw a line drawing from center of curvature to point of incidence. And if you extend it, that will be the normal, that is nothing but perpendicular at a point of incidence. Okay, now this incident ray makes an angle, that is the angle of incidence. Already in the previous concept I told you, always in rarer medium the angle is more, in denser medium the angle is less. And you know the laws of refraction. The incident ray and refracted ray both will be like either side of the normal, but not same side. So here this incident ray like one side, the refracted light should be opposite side, means this side, and it should make, it will moving entirely into the denser medium. As a result, it should make very less angle to the normal, so it moves close to the normal. The light ray after refraction moves close to the normal. So here what happens, if you consider another light ray, let it be another incident light ray, and this is also move like this, just like this one, same explanation. So these two light rays, when they incident, they are parallel. When they refract, they are, already I told you in beam of light rays, three types of beam of light rays: parallel, converge, diverge. So these two will be diverging beam because their distance is gradually increases. So this is one case, and second one, let it be an interface separated between denser to rarer, and let it be an incident light ray, and let it be principal axis of this curvature, and let it be center of curvature, and this is pole and this is focus point. Now here light ray moves from denser to rarer, and at the point of incidence, if you draw a line joining from center of curvature to point of incidence, we know that this acts as a normal, which is perpendicular line to the at the point of incidence to the surface. Now this is angle of incidence. Here light ray moves from denser to rarer. In rarer, the angle should be more. To maintain more angle, the light ray is pass like this. If you consider another light ray, then that light ray is also like this. So these two converges. So it is a converging beam. A parallel beam is converted into converging beam. When it is, when the light ray moves from denser to rarer and incident on concave surface. Here, concave surface. In brief, to understand many of the concepts, I will give you a table of form. Concave surface and convex surface, rarer to denser, denser to rarer. Here, in concave surface, rarer to denser, what happens? Is it the light ray diverge, converge, diverge? In concave is diverge. Obviously, in the opposite, in convex surface, that will be converge. And here it is denser to rarer, it is converge, and here it is diverge. Okay, see how this table is useful in day-to-day life. For example, have you ever seen the lemon placed in the glass tumbler in shops or wherever it is? Okay, how the lemon placed in the water in a glass tumbler, it seems to be bulged, means bigger one. From the compared with the actual size. If you remove the lemon from the water, it seems to be very small. But if you dip in the water, again it seems to be bulges. The reason is here lemon present inside the water. That is the lemon and this is water. The light rays comes from denser to rarer, denser to rarer, and here the tumbler wall is having curved surface, and in the curved surface the inward groove should be called as concave, the outward bulgous portion is called convex. So where the incident light will fall on concave surface. If the on the concave surface, the incident light will fall on concave surface and move from denser to rarer, the light ray should be converge. The light ray should converge means whatever the light rays come from this lemon, all the light rays converge at one point. Let our eye is here. We are observing from that point, and this converging beam, if we extend in backward direction. So the lemon image is just this much, because the image of an object appears when the light ray incident on the eye during the total traveling from the object to eye, from which the light ray comes from, it is not visible to the observer. And finally, in which direction it comes to the observer, so in that opposite direction if we extend to infinity, then the image appears in the backward direction of incident light ray. As a result, these light rays converge at one point. Though the light rays come from here, this is the real object, but the entire total length, if we extend in backward direction, this straight line path, according to the rectilinear propagation of light. Always the light ray travels in a straight line path, and it always forms an image in a straight line path, but not in curved path. According to rectilinear propagation, that light rays, though they bend and refracts, if you extend in backward direction, the lemon appears as a bulge. This is the reason. So, in many cases, like in movies, they see some persons as they become bigger and bigger one, and some of the people in movies they shown as they become smaller one. Okay, so these are all just by adjusting these lens used in the camera, and that adjustment between the distance between the lenses. Just by keeping that lenses, we can make the image either big one or small one. Like that, we can change. And our motto in this class to discuss how optical illusion can be created. This is also one of the optical illusion. Actually, the lemon will not, when we dip in the water, it will not bulges. It seems to be bulges, means it seems to be bigger one. Okay, become bigger one. But when we dip in the lemon in water, it will never become enlarged. Okay, so this is also an optical illusion. Okay. And the final concept in this is very important to remember. The final concept in this is ray diagrams. A convex lens, biconvex lens is usually the sideward view of a biconvex lens is like this. Biconvex, why should we call biconvex? When a light ray incident on the lens, always it fall on the bulged out surface. So it is a biconvex. Two surfaces are there. Two bulged out surfaces are there. In the combination entity is called biconvex. Okay? Yes. Here this is a sideward view of a biconvex lens, but symbolically to draw the diagram, we represent like this. If you extend this, you can get the same structure. Okay? So this is symbol of biconvex lens. In this biconvex lens, the midpoint, geometrical midpoint is nothing but 4, and if you assume a line passing through the pole, that will be called as a principal axis, and this curvature if you extend, you will get a center to the circle. The same center is also center to the curvature. So this is called center of curvature, and the midpoint of this pole is center of curvature is nothing but focus. Now, if an object is placed in front of this biconvex lens at infinite distance, that is an object. Okay, an object is placed in front of this, that this is an object. What is meant by infinite distance? Infinite distance is nothing but a distance from the lens at a more than 2r. Already told you the distance from center of curvature to pole is nothing but radius of curvature, because the entire curvature, this length will become radius, and to the circle it is radius, and to the curvature also this length is nothing but radius. So this is called radius of curvature. If you calculate r plus r, so beyond this 2r from the optical lens, whatever will be the position, if you place an object, that will be taken as infinite distance. If an object is placed at infinite distance, the light rays always comes from the object. They act as a parallel beam. In first concept I told you, from the source when they releases, they are acting as diverging. But after traveling infinite distance, all the light rays they behave like a parallel beam. So here object is placed at infinite distance. As a result, the light rays comes from this object which fall on the lens. They behave like a parallel beam. All those are parallel to principal axis. This parallel beam is after refraction passes through focus. There are 3 laws to draw the ray diagram. If an incident light ray is parallel to principal axis, after refraction, obviously it should pass through the focus. This is first law, rule. And the second one is, if the incident light ray passes through focus and incident on the lens, After refraction, the light ray behaves like a parallel beam to the principal axis. This is second rule. And third one is, if an incident light ray is incident through pole or optic center, without any deviation, the light ray is travels in the same direction. It travels in a straight line. These are the three fundamentals to use in the drawing ray diagram. Here, all the light rays, and one more thing is to locate image position or to draw the image in ray diagram, we should use minimum of 2 light rays. Minimum 2 light rays. Of course, we can consider more than 2 also, but if you consider minimum 2, then only we can find the image. Without using 2, by using 1, we cannot find an image or position of the image. That is why I have drawn 2 lines, because not to make clumsy the diagram. So 2 light rays intersect at one point. Where the light rays intersect, at that point if you place a screen in the sense that may be a cloth, that may be a paper, that may be any object where we catch the image, that is called screen. If you place a screen over here on this point, then the image of the screen can be seen here. In what manner? That is like this. In this manner, the image can be seen. That is called here the head and foot or interchange. That is called inverse image, inverted image. And compared to the object, the image is very small. Here, especially it is called point size. Point size, that doesn't mean that this much of size. If you keep a point, how much the point is having size, that doesn't mean that point size. Point size means it is the finest, it is the smallest size out of all the images. If this object is placed from here to different distance, it can form n number of images to the corresponding size of to the corresponding distance of the object. Out of all the images sizes, which one is the least? This one. Where the image is formed at focus, that is the least size. That is the meaning of point size. So at the focus, the image form is point size, inverted, and wherever the inverted images are always real images. Real in the sense we can catch on screen. The images we can catch on screen. Which images we cannot catch? I will tell you the combination. So these are the characteristic features of the image formed when object is placed at infinite distance. And second one, if the object is placed beyond center of curvature, more than center of curvature, what happens? If the object is placed beyond center of curvature, then we have to consider, to locate the image, we have to consider, I told you, 2 light rays, minimum of 2 light rays. I will consider one light ray which is parallel to principal axis, come from the object. Already I told you from rule 1 that light ray should pass through focus. So passes through focus like this. And here object is very close to the lens. Then there is a possibility the light ray come from the object, incident with some angle, inclined direction. So if I consider such an light ray which is passing through optic center, that will be traversing the straight line path. Here the two light rays intersect. Here the light rays come from the top of the object. That is when at the intersecting point we have to locate the image top. Of course, in practically if you do the same thing, you can observe the image head down and the foot of the image object at the top in the image. Okay, but in ray diagram here The two light rays comes from the top of the object. As a result, here we should draw the top, the bottom, and the foot at the top. So this is image 2. Comparing object, it is small in size. The object is small in size and it is inverted. Means top and bottom interchange. Inverted, and this is real image. This is a real image. So these are the two conditions. Now the third one and important thing is if the object is placed beyond focal, at a less than focal length, at a distance of less than focal length, then consider a light ray which is passing through parallel to the principal axis, and this light ray will be travel through focus after diffraction. The second light ray which comes from this object, we should not consider like this, which is makes an angle, because these light rays refracts, but we cannot place the refracted light ray passing through these positions. Okay. To that, if you consider light ray which comes from the object passing through optic center, it travels through the optic center in a straight line path, and these two light rays, how they are seen to be diverging beam. So this diverging beam, is it possible to intersect at any point? No. In the direction of progression, the two light rays, they are parallel, there is a possibility. If they are converging, there is a possibility to converge. But it is a diverging beam. Diverging beam will never intersect. If they do not intersect, there is no possibility of locating image. To locate the image, if we extend backward direction, these two light rays extend in backward direction. This here we can find a virtual intersection point. Virtual intersection point. At this point, the image will be obtained like this. Means here the image is same side, enlarged and erect image. Erect means as it is. Enlarged means big one. And it is same side. And this is it real image or virtual image? That is not really obtained. That is a virtual. Real images we can catch on screen and we can see. Virtual images we cannot catch on screen, but we can see. An example for virtual image, through a plane mirror, you can see your image. But can you place the same image over any other object? No. In theater, they focus the image on screen. That is a real image because they use a biconvex lens. And the object is very close. As a result, they can focus that image wherever they want. So that is a real image. Okay. These kind of virtual images we can create by placing object very close to the lens, and this can be seen as a real object, but not the object placed in the same place. The same principle is used by Hrithik Roshan in that movie to form that optical illusion. What the thing he used? An object. He doesn't need real diamond. The image of the diamond is enough to form another image. He used an image of a diamond placed very close to the lens, camera lens, and this forms an image at a required position. To adjust this position, they need some mathematical and scientific knowledge at what distance the object should be placed to form at a required distance from the lens. So this is the concept of ray diagram in a simple manner. Thank you.